How's it going, everyone? It's Tommy from Western 5000. Today is January 19th, 2021, and today we're going to focus on the potentially major Midwest and Northeast snowstorm that could happen headed into next week. And we'll also talk about the Santa Ana winds of California, the Pacific Northwest snow, and the New Mexico snow. But before I begin, make sure to subscribe if you want to see more weather-related content. Make sure to like if you like this video, and make sure to turn on post notifications if you want to see even more weather-related content. So let's begin by first taking a look at the GFS model, and I know you guys are seeing the same thing of what I'm seeing, and you're thinking the same thing of what I'm thinking. You're seeing a pretty big snowstorm in the Midwest with a large area of snow extending from Wisconsin all the way down to Iowa, and this will extend further and further eastward, and it could raise the potential of a potentially major northeast snowstorm that could affect not only the interior northeast but portions further southward if the cold air is in place. And if you take a look at the forecast hour 144 hours from now, you see that we're still very far from the actual date of when this event is going to happen. I would say between 7 to 5 days. It really depends on timing because the European is taking this storm a lot slower than the GFS model, because 7 days from now and 168 hours from now, it's pretty much centered still at the Midwest. However, compare that to GFS, and the low pressure is already nearly off the coast of the Northeast by day 7, or 7 days from now, 168 hours from now. So there's a stark contrast between the speed of the low pressure system, and which tells me that the forecast is even more uncertain now, because we're not even certain how fast or at what day this exact event will occur in the Midwest or in the Northeast, because there are stark differences in the speed of this storm from both two of the most reliable computer models. But you see, let's first take a look at the GFS. Let's begin all the way from the beginning, and this low pressure system will pretty much originate from the Pacific Northwest, which is typical for this year. We've been seeing a lot of low pressure systems come off the Pacific Northwest. However, this one will be stronger than others, and it's going to encounter an area of unstable air to the point where this snowstorm will be bigger than a lot of the others we've been seeing in the past several weeks, where it's mainly been quiet and a lot of storms coming off the Pacific Northwest have been weak. But you see that the low pressure begins to get its act together. It begins to it begins to really take advantage of that unstable air mass, and we really begin to see the convection start along the northwestern portion of this storm, right around the 540 millibar contour line. And if you don't know what that is, that's pretty much the line that separates freezing temperatures from non-freezing temperatures, or pretty much the baseline. It's around the ballpark with separating the temperatures. However, it's a good contour line we use to represent where exactly that polar jet stream is, and where that instability exactly is. And you see that, and when there's a dip in the 540 millibar contour line, that tells us that there's a lot of unstable air, and we do see a decent enough dip on the western side of this storm to really get convection going on the eastern side of this storm and really get a larger swath or area of snow falling throughout the Midwest. And you see that this storm will move it, and it has a lot of strength as well. It's coming off the Pacific Northwest with a lot of moisture, so although it's going to go over the Rocky Mountain ranges, which is typically weakens a lot of these low pressure systems to a point where it gets very difficult for the low pressure to regain strength on the eastern half of the storm. And the reason why storms in general weaken as they go over mountain ranges is because all the air is forced upwards once the wind encounters the mountains, and as a result, since all the air is forced upwards at a rapid rate, it's forced to condense at a rapid rate to the point where by the time it's at the lee side part of the mountain, it pretty much lost all of its convection. It lost all of its latent heat as a result of the rapid condensation that occurred over the mountains, and it just loses a lot of its energy as it heads over the lee side of the Rocky Mountains typically. However, since this storm is strong enough and it's going to encounter an area of unstable air, it's going to re-strengthen and maintain its strength despite going over the Rocky Mountains. And you see by 5 days from now, Sunday, supposedly the European definitely disagrees with it. It's taking the storm a lot slower. If we compare it to the European at 120 hours, you see that the low pressure is still hovering right around Colorado, while in the GFS model, it's already in Kansas. And from here on out, the gap between the GFS and the European model widens significantly, as by the time the GFS model passes the Rocky Mountain ranges, the storm is going to speed up rapidly compared to the European model. So if we continue to move forward, you see that 138 hours from now, we see a large swath of snow, and this snow, I think, based off of what I'm seeing in the radar, in the futurecast radar of the GFS, it looks capable enough to dump maybe up to 10 inches of snow in a lot of these areas, and this could include the big cities like Milwaukee, Green Bay, and even Minneapolis if the storm moves just to the north enough, which is still highly uncertain. But if we move forward to past the 6 day mark, you see that there's still snow throughout Michigan, throughout Wisconsin, and for a lot of the Ohio River Valley, they're still under rain. However, there's still a ton, like I said, a ton of uncertainty. 6 days out, there's still a lot that could change. But moving closer to a 7 day mark, that low pressure eventually moves eastward to the northeast, and the timing of this is still uncertain. However, I will say with confidence that it's likely that some sort of low pressure system will move through the eastern half of the United States and will dump snow, especially more specifically on the northern portions. How far south will that snow line go? How much accumulation exactly? That still has yet to be seen. We still need to determine how strong this will be. And also we need to determine the position of this jet stream, because also the speed of this storm will play a factor, because if it moves faster like the GFS model is stating, then it's less likely that we're going to see much more it's unlikely we're going to see as much accumulation as the European model, because obviously since the storm is moving fast, it has less time to dump enough snow over the Midwest and Northeast. However, there's another factor that's interesting, which makes the timing of the storm especially important and the speed of the storm especially important. Because let me switch over to the 500 millibar height and MSLP. You're to really get a better comparison to the European model, and let's compare the two 120 hours from now. So, well, let me go even further back, the 4 day mark, which, keep in mind, is still considered an uncertain time frame for weather forecasts. Let's go back all the way to the 4 day mark. So you see that both the European and the GFS at this point are in very identical areas, pretty much the same strength as well at 102 millibars. So there's much higher confidence that the low pressure will be somewhere around this vicinity, right around Nevada, California, about the time we hit Saturday this weekend. And so the speed disparity isn't really visible or isn't really noticeable yet this early in the run, and it won't really become noticeable, and the gap between these two low pressure systems won't the gap between the low pressure systems in each computer model won't widen until later during the run, which is interesting. However, if we move to the 120 hour mark, we begin to see that gap disparity really grow, as a GFS model is already at Kansas at this point, while the European model is still lingering in Colorado. And you might be asking, why is that? Why is the GFS taking a little bit more of a faster storm and the European is taking a little bit more of a slower storm? Well, we have to take a look at the position of the jet stream and pretty much the temperature, the differences in temperature. If we look at the GFS model, I noticed that there's a little bit more of a pronounced dip in the jet stream. There's a little bit more of an Arctic dip. There's a little bit more Arctic air that's filtering further southward, and it's to the point where it's getting much closer to the warm air of of the southern United States than, let's say, in the European model, where the cold air is still mainly trapped in Canada. And what this means is that since the cold air is moving further south in the GFS model and there's a little bit more of a dip, there's a lot more unstable air in the atmosphere in the Midwest, which, and when there's more instability, when there's very cold Arctic air very close to the less dense warm air, then that means that there's a lot more wind, since that dense Arctic air will want to filter into that warmer, lighter, denser air. And since there's more wind, it speeds up the winds in the upper levels and the lower levels of the jet stream, to the point where the winds will be strong enough to move the storm a lot faster. When there's more instability, the jet when there's more of a stark contrast and a I'm trying to find the right word. When there's more of a stark contrast in temperature right around where the jet stream is, or when there's more instability, then the jet stream winds increase significantly, to a point where the winds in the upper levels of the atmosphere are very strong and they're going straight westerly, which is the reason why the GFS is favoring to speed up this storm, since it expects the Midwest it expects a storm to encounter an atmosphere that's more unstable, and since the atmosphere is more unstable, the winds will increase, which will force the jet stream winds to be a lot faster, and that'll force the storm to pretty much accelerate much faster than the European, where there isn't as much instability, and a lot of that Arctic air is trapped further north, right around Canada, and it isn't really creating an unstable atmosphere to increase those jet stream winds. So, which is the reason why the European is slower than the GFS, much lower at that, because, like I said, only in even 7 days from now, it's still in the Midwest, while by in 7 days in the GFS, it's almost off the coast of the Northeast entirely. So there's a huge speed disparity, and it's very important that the computer models keep that in mind. However, since the GFS is moving faster, it's more likely to be a weaker storm. Now, some of you might argue, well, that doesn't make sense, because if there's more of an unstable atmosphere the low pressure will encounter in the Midwest, then that means that the low pressure in the GFS model should be stronger, and you would be correct. However, the unstable air in this area won't be enough to really strengthen it into epic proportions, and it's still going to be relatively weak despite the increased amount of unstable air in the Midwest compared to the GFS. And the thing is that since the storm is going to move faster, it's going to move so fast to the point where it's going to miss that second bout of cold air that's going to filter in on the back side of this, which would make the storm really strong. Compare that to European. While initially the European won't encounter as much instability, since it's moving so slow, it's gonna move slow enough to be able to capture a little bit of that Arctic air that's on the back side of this, and as a result, the European is a stronger storm since it's moving slower, since it's able to slow down to the point where it could wait for another round of instability to occur and strengthen this storm much stronger than what the GFS model is taking, since the storm is going to move too quick to wait around for any sort of unstable for the second Arctic blast to move into low pressure, which would otherwise strengthen it. But it's very important. The speed is very important to determine the speed and to determine the strength of the storm, which could definitely make an impact on how much snowfall accumulation you'll experience all throughout the Northeast and the Midwest. If we were to take a snowfall forecast for the current European model, it's hard to say because, like I said earlier, the storm's moving very slow. About 7 days from now, it's still in the Midwest, it so I don't really like to make snowfall forecasts beyond the 7 day mark, especially. And it's difficult for me to make it even beyond the 5 day mark. It's a little easier with the GFS since it's moving faster. So, to the point where we could make that snowfall forecast within the 7 day time frame because it pretty much passes the entire Northeast and the Midwest, the pretty much the entire United States within 7 days. However, that's not the case for Europeans. It's moving too slow to really give a confident forecast of what to expect in the Northeast and the Midwest in terms of snowfall. However, based off of my experience, it seems like this storm is is definitely more likely to be a much more significant snow event for the Midwest and the Northeast just because it's stronger. Even though I don't want to make a confident forecast of how much snow beyond 7 days. However, just the fact that this storm is stronger and it's gonna be stronger thanks to this polar vortex that's gonna move behind this storm, it's more likely to dump heavier snow in the Northeast, and it's going to be important to determine the speed of this storm. If it moves slower, then there's more likely of a chance that the snowfall accumulation increases because it'll be able to capture a second wave of Arctic air behind it that will increase the instability and strength of this storm. And if it were to move faster, while there still would be a major snow event for a lot of the Midwest and Northeast, I would say it's unlikely to be as strong or as potent as a European model. But who knows? When I'm talking about a forecast beyond 5 days out, there's still a ton of uncertainty. These two computer models can definitely be completely wrong. We could see snow as far south as Virginia, or maybe only affect the interior northeast portions or the higher elevations of the Northeast. We just don't know. It's just very far. But what I could say with confidence is that there will be a low pressure that moves through the eastern half of the United States, and I think the most likely people who will experience snow from this are the extreme northern portions of the United States, while for those south of that area, it's very uncertain for you guys where that rain snow line should be. So just stay tuned for your local forecasts and keep watching my videos if you want to see more of this stuff and more updates on this storm. I'll be glad to give you guys more forecasts whenever you need it, and just stay tuned. So really the key is the speed of this storm. If it moves slower, it's more likely to be stronger and dump more so. If it's faster, then it's less likely to dump as much snow. However, the position is still a factor. We need to see how the jet stream positions itself. There's still a lot of factors we just need to determine, and we just need to stay tuned for updates in the computer models. But outside of this storm, well, let me show you guys my current forecast map based off of what the GFS and European model is stating. And I think the heaviest snow will be in the Northeast and maybe moderate snow just south of that and further to the western portions of the Midwest. So keep that in mind. But there's still very uncertain, like I said. But now let's move on to other forecast for other stuff that's going on to the United States. We do have a little bit of snow in New Mexico where you could receive up to 10 inches in some areas, right? And you see the heavier bands are pretty much along the border of New Mexico and Colorado. However, this will eventually die out since there won't be a lot of unstable air for this storm to work with. It's going to be very far from any sort of body of water, so it won't really have much of a future. However, for California, today you guys need to watch out for very high Santa Ana winds with wind gusts potentially gusting over hurricane force in some areas, which is extremely dangerous. A high wind warning is issued all throughout the California coast, and it'll be a major wind threat, and unfortunately could increase the chances of wildfires, especially since you guys are in a drought in California. So let me show you guys the wind forecast for coastal California, and you see that for a lot of coast, you see that if we move to 12 hours from now, you see the low pressure forms off the southwestern coast of California, and it's just going to, you see the strong winds coming off the Pacific Ocean, and we're seeing strong winds in even more inland where we're seeing the darker blues, the darker greens, which represent 30 mile per hour sustained winds, which could be which I wouldn't say devastating, but it could definitely be damaging, especially since the wind gusts could gust over 60 to 70 in some areas. So keep that in mind all throughout the West Coast because it could potentially be major if you don't take the right precautions. But anyways, guys, I guess that's it for this video. I thank you guys for watching. Make sure to subscribe if you want to see more weather related content. Make sure to like if you like this video, and make sure to turn on post notifications if you want to see even more weather related content. And make sure to share with friends and family who may be interested in this potential snowstorm or any other weather event that could occur in the United States. And I thank you guys for watching.